for showing up. I know you guys would rather be out trick-or-treating, and there is a bowl of candy here. Please help yourself. But it's a pleasure of mine to introduce to you another colleague of mine, Beau Downing. Beau came to NRD from FWP, and we feel really lucky to have stole another great employee from the state. Beau's working on the tributary restoration projects for the Upper Clark Fork River Valley settlement, and today he's going to talk to us about the Blackfoot complex, but also today Beau started a project on Blacktail Creek out at the headwaters where Continental Drive and Highway 2 come together at the 9 miles. So we're looking for good things from Beau out there, and also he's done a lot of restoration projects in Browns Gulch, which is just down the road. So he's very familiar with our part of the woods, and Beau is actually a marathon runner, and he likes to run through the woods, and he's got 2 small boys, and he wants to get home and take them trick-or-treating. So he's going to talk fast. Thanks, Beau.
We understand.
Yeah.
Thank you.
Like Pat said, I'm Beau Downing with the Natural Resource Damage Program, and I normally try my hardest to stay outside of Butte city limits because you get sucked into the black hole associated with Superfund at Butte, and you seem to never come out. So I try to stay, Rocker, Upper Blacktail Creeks, about as close in as I'm willing to get with actual dirt moving projects. But happy to be here and talk to you guys about one of the larger restoration projects that I have going on at the Upper Blackfoot Mining Complex. And my colleague Dave Bowers from the Department of Environmental Quality here. So when you see the word remedial or remediation, or I talk about that, that's Dave's shop. And his role at DEQ is to deal with the remedial side of things at the Upper Blackfoot Mining Complex. So if you have questions about chemistry, site conditions, history of the mine, Dave's the one to ask. I'm here to talk about how we have approached restoration, design, and construction at the Upper Blackfoot Mining Complex, because the way it's set up is we are tied to the hip with remediation at the UBMC. I might call it Upper Blackfoot Mining Complex. I might call it UBMC. More often than not, I'm going to start calling it Mike Horse. That's kind of the nickname for the site up there, and for reasons that will become apparent soon. But when I'm up there, my job is to integrate the restoration of floodplain and stream channel with the remediation that's occurring at the Upper Blackfoot Mining Complex. And we're doing that hand in hand. Just to give you the lay of the land, the Upper Blackfoot Mining Complex is about 12, 15 miles east of the town of Lincoln in Lewis and Clark County. So you head out Highway 200, you can turn right, head on the Lincoln Road back toward town. You'd pass the UBMC repository, which is that brown oblong football looking thing. And then if you head a little bit further east and turn in on the Mike Horse Road or the Meadow Creek Road, you get to the Upper Blackfoot Mining Complex. As the flyer said, the Upper Blackfoot Mining Complex, or Mike Horse, was a mine that began operating in the late 1800s and was really viable through the Second World War. This is a town, or the picture of the Mike Horse mine workings in Mike Horse Creek, which is a super high gradient stretch of first or second order high gradient stream. There were several different mine adits and things that contributed. The ores that they used to extract primarily lead and zinc. So there was this whole mining complex up at Mike Horse Creek. And of course, they left in the late 1940s, early 1950s, and left behind a legacy of what you get when people leave mines that are no longer viable or functional. So you get things like mine adit discharge and stuff. So this is one of the mine adits in that Mike Horse Mine Complex several years after folks have walked away from the site. This is a picture of the tailings impoundment at the Upper Blackfoot Mining Complex. So we're looking upstream, up valley. Bear Trap Creek exists there off to the picture right below the road. There's a kind of a water-filled mine tailings impoundment. Mike Horse Creek and all that Mike Horse mine workings would be up and to the right, up one of the steep drainages off the picture this direction. There was a town site where workers and family members lived at the UBMC, and this picture is kind of taken from where that town site is, and we'll talk about the town site more later, because most of those buildings, all those buildings are gone now, and we're using that as a source of clean material for the restoration components. So you had a big mine complex up the Mike Horse Creek to the right, and then they were floating tailings out into this pond and on this dam. And then this is what it looked like not long before remediation of the site began. This is a mid to late 2000s photo of the mine tailings impoundment with several 100,000 cubic yards of mine tailings living behind it. It discharged water from the base of the tailings impoundment, and you also had Mike Horse Creek coming in just below that mine tailings dam, and so you get classic mine impacted streams. This is Bear Trap Creek at the Upper Blackfoot Mining Complex. So lots of not great things happening at the Upper Blackfoot as it relates to contamination. Then, to make matters worse, in the mid-1970s, a large rain on snow event came and blew out the mine tailings dam and mobilized several 100,000 cubic yards of those tailings down into the Blackfoot River, the very starting point of the Blackfoot River. So Bear Trap Creek comes in from the top, down through the mine tailings. Here's Mike Horse Creek coming in from the right. This is lower Bear Trap Creek, and the geographic starting point of the Blackfoot River is just downstream out of the picture. So not only do we have several 100,000 cubic yards in the mine tailings, we got all the mine impacts up Mike Horse. We had a big tailings dam blowout that introduced several 100,000 cubic yards of material through the headwaters of the Blackfoot and down into the Blackfoot River that extended several miles downstream. So you've got a lot of mine impacted areas at the Upper Blackfoot. This is a 2005 aerial photo to kind of get you guys familiar with the lay of the land. Anywhere where you see bright brown things, or you see rectangular features or non-rectangular features, triangular features, all the brown barren stuff is mine tailing impacted areas. You've got the impoundment up there with some water in it, but there's several 100,000 cubic yards of tailings living there. And then you've got all the mine infrastructure and associated contamination, tailings impoundment, all kinds of funky, weird stuff that's in Mike Horse Creek, which takes off up to the right there. So that's kind of what it looked like before we moved in and started the remediation and restoration of the Upper Blackfoot Mining Complex. As a little bit of background, in 2007, an engineering evaluation and cost assessment analysis was developed and completed for ASARCO, not ARCO, ASARCO, and the Forest Service for the UBMC, that outlined all the removals that needed to occur, what types of restoration and thing could be done, and that ultimately led to essentially a cash settlement in bankruptcy court with the SARCO. So there was an influx of money that came into the Upper Blackfoot Mining Complex in early 2008 to address the remediation and restoration of the site. There are a couple of different settlements, but when all was said and done, we had about $35 million to do the remediation and restoration of the Upper Blackfoot Mining Complex. And that kind of plays into the future of the site. Most of it is Forest Service owned land. Some of it's trust land now that used to be owned by ASARCO. And then the Natural Resource Damage Program was party to the settlement for restoration of the site. So there was kind of this three-legged prong of federal and state agencies that decided to enter into a watershed restoration agreement for the Upper Blackfoot mining complex that envisioned completing all that work inside that ECA, from the mine's tailings removal, the cleanup of Mycor's Creek, all of Bear Trap and the headwaters of the Blackfoot River, down to a boundary that was defined in that ECA. So those settlement dollars came in. Remediation kicked off a bunch of their preliminary investigations, their feasibility studies, all the stuff that happens on the DEQ side of things began in 2008. Simultaneously, the Natural Resource Damage Program embarked on gathering the information they would need to provide the best function-based restoration of the site as we could. So one of the first major work products that came out of what the Natural Resource Damage Program and other consultants gathered was a conceptual restoration plan for the Upper Blackfoot mining complex. So that's kind of like, here's ideally what we want to do at the Upper Blackfoot mining complex. So it evaluated the existing conditions. We looked at limiting factors, what we thought we wanted to look like when all said and done. Restoration concepts were developed by REACH, all the different types of treatment. And then it's not highlighted here, but integration with remedial actions. So the watershed restoration agreement between DEQ, NRDP, and the Forest Service said we are going to endeavor to save money by implementing remediation and restoration concurrently, simultaneously, however you want to put it. The goal was to integrate all of our actions together so that we could realize some economies of scale when it came to remediating and restoring the site. And at all phases through the project, we've solicited agency input and feedback, and that's been a back and forth between remediation and restoration on design components, implementation strategies, things like that. So this really laid the groundwork for that. Moving on from 2011, in 2013 we had a 50% preliminary design phase. That's where we really started to drill down on, okay, remediation's gone through their design stuff. We've got some remedial design surfaces that other consultants have developed for the site. We think we know where our removal surfaces are going to be. Let's start designing what restoration is going to look like on top of those surfaces. And while that's going on, we're getting those designs together. We're trying to integrate those with remedial actions that are occurring at the site. And we're taking a coordinated multi-agency approach to the design of the stream channel and floodplain and the hill slopes that are going to be up there at the site. So as part of restoration, we broke our project areas into various stream reaches. From a stream restoration side of things, when you have a really big complex project like this, you're going to break it down into viable chunks that make sense geomorphically for slope, channel type, things like that. And we're going to break those apart and define them as reaches. So reach 1 and 2. Reach 1 is the Mycor's Creek. Reach 2 is Upper Bear Trap through the impoundment area. Reach 3 was Lower Bear Trap. 4 is Blackfoot River proper down to Shoey Gulch or Shave Gulch, depending on who you talk to, which is up here at that break line. And then moving downstream through Reach 5 and 6. So we broke down our restoration areas in these areas into these different stream reaches. And this is one of those deals where, okay, restorations come up with their own reach breaks and naming conventions and channel alignment stations and all this fun stuff that you do on the restoration side of things. And then you put it on a map with the remedial design, and they're operating under a completely different valley stationing system. They've named things different. Their breakpoints don't necessarily line up with our breakpoints. And so it's one of those processes or deals where you learn how to communicate with one another. Especially when you're essentially talking two different languages about sites, locations, and things like that. So that's just one of the deals with integrating remediation and restoration. So what types of things dictate our restoration design up at the Upper Blackfoot Mining Complex? Well, we're operating under various different design constraints. I've just listed a few of them here. You've got remedial actions, which are the tailings removals. You could spend all $39 million characterizing the site to know exactly where all your contamination is, how deep it is, what the chemistry of that contamination is, or you can do targeted evaluations and investigations of the site, save that money for actually cleaning it up. But what that leaves behind is, for lack of a better term, a best guess on the remedial side of things about where the contamination begins and ends, the volumes that are associated with it, and what that means for restoration. So you've got these remedial actions, tailings removals. What's that going to mean to restoration in the future? In Reach 1, this is a picture of the upper my course. So Reach 1 was the restoration of the stream and the floodplain in my course creek. But you can see there's a whole lot of infrastructure that existed at the place. Some of it still exists because it feeds the water treatment plant that I talk about right there with Reach 4. All the mine adit water is now treated forever at that little red building. So there's a bunch of infrastructure in My Course Creek that relates to getting water delivered to that water treatment plant that restoration had to design around. And then there's places like the water treatment plant, there's confluences of tributaries, all sorts of tie-in elevations that really dictate where you're going to be able to build your stream channel and floodplain, and it drives kind of the whole ability to adapt the site. So you've got fixed points in space, they have to be there, your channels got to meet up, they've got to make sense geomorphically, and so you've got these fixed constraints that you have to deal with at the site. And so what that looks like when you're actually on the ground and remediation's doing their thing and restoration's doing their thing, we spend long periods of time over the winter getting a big bid package together that has all the remedial components, all the restoration components. Then we go and we actually start constructing. Remediation starts first. They remove contaminants. They determine it's meeting their site-specific cleanup levels. They leave behind a surface. That surface may or may not match the remedial design surface that went into the bid package, and therefore restoration was designed on top of. So we take that bid package restoration design and we look at the remedial action change in field or change of site conditions. We may hit the actual removal surface in the bid package like 1 out of every 100th time. There's so much variability in a site that's been affected by big outburst floods from dams and things like that. Is that remedial action, or there's going to be a change in site conditions? We evaluate that change against our restoration design. We say, okay, that surface you left behind is way above, way below. We're kind of in the ballpark of where we need to be. So then we look at, okay, so can we change to meet that new existing condition? Sometimes you can, sometimes you can't. But what you do is evaluate whether or not that localized change can fit with all your known tie-in points and constraints at the site. So say you have some alignment shifts or some vertical adjustments you could make in a certain place. It all has to tie into those known points in space that you have at confluences, stream channels, stream crossings at the water treatment plants, a fixed point in space. So you have to evaluate that against the desired change to meet the new remedial condition. If it can't fit with those known tie-in points, like you can't make water flow uphill, we can't ramp water up and over a big hump in the floodplain or something like that. So does it fit within our known tie-in points, and can we revise? If not, then we revise our cut fill volumes and stuff to move back to that original restoration bid package design. So our volumes might decrease, our volumes might increase, but we're essentially not changing any components of the restoration based on a change in field conditions. However, if it does happen that we can change based on the remedial surface, we then go and look at, does the change meet our design criteria? So we have criteria like we need to be able to move sediment, we need to be able to move water, we know our desired stream slopes. So basically, I don't know if you've ever seen this before, but this is called Lane's balance or Lane's diagram. So if you balance your sediment size and sediment volume with your stream slope and your delivery of water, then your stream will stay stable. You won't degrade or grade your stream channel. So if we're making changes, we want to make sure that we're keeping our arrow pointed at that kind of dynamic equilibrium phase. We can swing in and out a little bit. We can move these arms left or right a tad and keep that arrow pointed close enough to the middle. But if that swing is going to be too great, we lose our geomorphic continuity at the site and we have to reevaluate what we're going to do. So if we can't keep things in dynamic equilibrium after we build them, then we go back and evaluate what it takes to get the restoration surfaces up from remedial surfaces to build the stream channel in the floodplain. If we can still make this thing work with our design changes, then we'll revise all of our channel design components that we can adjust to meet that new remedial field condition. So this is an iterative process that's going on through an entire construction season. It goes on after a construction season's over, and you can evaluate your remedial surfaces over a winter, and you start looking at how you fit your restoration actions into what remediation has taken out. So I put this photo in here because what I'm illustrating is it was a best guess to figure out where the basement of all this contamination at the mine tailings impoundment area is. It's a best guess below this where the base of your contaminants are in the floodplain from the flood outburst. But obviously, when this is filled with water, all this stuff's liquid, and before you've started doing the remediation, you don't really know where this basement is down here. You don't exactly know where your surface is, or if it's going to line up or fit with what you've done from a restoration design standpoint. So what you do is you let remediation do their thing. They dig. They start meeting their site-specific cleanup levels. Then you go back and you reevaluate what's left behind. So this is a typical restoration surface that's left, or a remedial surface that's left behind following remediation of a site this size. All the flow from the natural Bear Trap Creek that's flowing into the site is being bypassed down a ditch that's just on the other side of these trees. So it's in a lined ditch, all the water's going around the site, and you're left with this dry, dirt, but clean surface that may or may not necessarily line up with what you were expecting to find post-remediation. So all that stuff gets surveyed, you evaluate it against your restoration design and say, boy, it's going to be really expensive if we don't make these adjustments, or boy, we can make some alignment shifts based on what they've done to optimize the site for restoration. So I put this plan set up here because what that really means is so we've got a bid package design, and so in 2015, this black line was our original bid package design for the stream channel, and we had it go out over here. And if you start looking at this color ramp for this heat map, you start seeing that the cut required to get to the floodplain or channel subgrade elevation over there was quite significant. If you look over here, we actually had an old relic channel for part of it. We had some low points on the floodplain that required fill. So what we did was we shifted that whole channel alignment to try and minimize, one, the amount of cut, and two, the amount of fill that was required at the site to get our channel alignment to make sense based on the change in remedial surface. So this is all occurring in real time. You get these surfaces, you take them back to the shop, the engineers do, the channel restoration designers. We sit down and say, here's what we have now, here's what we thought we were going to have. We need to make these changes from a cost saving standpoint, from a functional standpoint, from a mass balance standpoint. We've got finite resources to get things done, so we have to make these shifts. So just to drive that message home, these are kind of some of the examples of where we wanted our floodplain and our stream channel versus what the existing ground looked like pre and post removal. So you can see that there's always variations and adjustments that need to be made to get at how you're going to restore these locations. So we've done all that. We've got all of our new alignments. We're looking downstream. They're still continuing to remediate. They're cleaning up the surface. All this stuff's meeting the site-specific cleanup levels. It's a surface that's ripe and ready for restoration. So what we do is then we get all those new design sets, new channel alignments, new floodplain elevations off to the contractors, and they actually start doing the work. So you can see here, there's channel subgrade, nice meandering channel. These are stakes for the in-channel components of the project. So that's that shifted design alignment and floodplain elevation looking down toward remediation. Looking at that from the opposite direction, this is looking upstream. If you look real careful, you can see that channel subgrade and that new floodplain adjacent to a haul route and then all this other contamination that's at the site. So when I say integration and working together, there are many times where restoration's occurring literally right on the heels of remedial removals. So that design iteration process occurs pretty quick. This is looking down toward that dam site now that the dam is mostly removed. You can see our channel alignment. We've started doing floodplain restoration, hill slope restoration. This is Bear Trap Creek. We've got a big heavy revegetation component that from plants that were grown from seed, harvested in basin. So we've moved past all that remedial surfaces and gotten to where we've been able to fully restore the channel and the floodplain. Just keep your eye. This hump is a really good visual marker for kind of getting yourself oriented on the landscape there. So that was like 1 year post-restoration. Here's 2 years post-restoration. Again, there's that hump down there. I'm a little bit further upstream than where that last photo was taken. That last photo was taken from down here. But that's about 2 years worth of growth. And then there's July of this year. Sorry, I can't seem to, when I'm out there, I'm like, I know I've taken photos from here before, but I can't remember if I did with my phone sideways or up. But there's that same hump, and then this is like 3 years worth of willow growth in Bear Trap Creek. You can see that the seed's starting to take, and we've got a nice restored floodplain and stream channel that is close, but is not the same as what was in the bid package when all this was let. So we knew what we thought we wanted to do. Site conditions change somewhat, and we make those adaptations, and you'd never know it looking at it that we had to go through that whole process. Something very similar happened up in Mike Horse Creek. So the stuff I just showed you was done in 2015. In early 2016, we moved into Mike Horse Creek in 2016. This line, this bottom solid line, was the proposed or design remedial surface prior to new information being gathered. The black line with the step pools was the original designed channel. Site conditions changed. The remedial engineers decided they needed a geotextile liner to separate surface water from entering the mine works. There's a bunch of mine workings and other things that are in this area. So they wanted to put a liner in to keep surface water from subbing out and increasing the volume of water in the mine pool. So as you can see, we had to make a big restoration design shift from what we thought we were going to have to what we ultimately ended up with. So we're just shifting everything vertically here. And then as you can look, also sometimes site conditions dictate that you want to go around something or move in a different direction than what your proposed alignment was. So your lateral and vertical shifts occur in places when you're adjusting to those remedial locations. So this is the exact same place that I just showed you on that plan set. So just underneath, this is actually the stream channel being built in the middle. It actually looks high here because they haven't brought the floodplain up to grade yet. But this is all above that geotextile liner that's keeping the surface water separate and not entering the mine pool below it. So this is looking down valley and around the corner. All the old mine workings are kind of up here to our left. There's a road right here. So this has all been remediated. It's all meeting its site-specific cleanup levels, and now we're making those vertical and lateral adjustments from a restoration side of things. That side of it's challenging. The good thing about trying to restore landscapes like this is all the water's already being handled somehow because they needed it dewatered for remediation to be successful. You don't always have that luxury. I've went to 3 restoration sites today, 2 in Browns Gulch and 1 on Blacktail, and they're really, really, really wet, and water management's really, really hard. And it's actually kind of nice to work in a place that was this dry. So once again, I can't seem to take photos in a consistent manner ever. This is that same spot, but looking upstream. So last time I was standing right here looking downstream at that construction equipment. This is a year post-restoration of that upper end of Mycourse Creek. And once again, all these plants were harvested, all the seed were harvested, and all the plants were grown specifically for this project location. This is lower Mycourse Creek. You can see that our proposed channel alignment was here. Turns out that Mycourse Creek, when it was being filled up with a bunch of mine tailings and waste, actually had a low point that our red line, which is the actual as-built channel alignment, ended up following. So once again, we're adjusting to those site-specific conditions. One thing I want you to look at and pay attention to is this is actually a road. This is a plan set of a road. We call it the Horseshoe Bend. Our original alignment for the channel and a culvert were here. Site conditions changed and it got moved here. And I'll be able to show you kind of what that ended up looking like in the real world. So here's our little U-shaped, high gradient Mycourse Creek Valley. We'd originally planned to put the channel and the culvert somewhere over here. This was the obvious low spot after remediation had removed all the mine tailing components and contaminants. And so we shifted that alignment and changed where we put our open bottom arch culvert. So once again, just adapting to changing site conditions. Fast forward to 2017 and 2018, and the work that we just completed or are completing right now is underway. But I wanted to kind of show you how the remedial side of things look. Oop, I lost my mic. This is a remediation plan set, a remediation design sheet. Bear Trap Creek comes in here, Mycourse Creek comes in here. They combine at a confluence point, and this becomes Lower Bear Trap Creek. So this is the mine tailings. This is the mine waste removal estimation. And that's kind of what the plan set looks like. There's the valley stationing. It doesn't line up with our channel stationing, but that's what we are designing to. We are designing to kind of what this proposed remedial surface is and working with that. So turns out that, it doesn't always happen the way you want it to in those places. So here we are. Here's Upper Bear Trap Creek. Here's Mike Horse Creek. This is looking down valley. So you can see the remedial surface is in red. Doesn't necessarily match up with what we needed from a channel construction standpoint. So we made some adjustments. Here is another section of Bear Trap Creek. They didn't remove anything in the area of where the channel was going to go. So we do some design shifts and some channel alignment changes to kind of match up and minimize that amount of excavation that has to occur. So in a constant iterative process on design there. This is Mike Horse Creek for that plan set that we were just looking at. Mike Horse Creek is being built and comes down here. Bear Trap Creek would be coming from this direction. So this is a lot of times what our surfaces look like that we're working to restore out there. This is looking downstream, just below the confluence. So Mike Horse came together with Bear Trap Creek, and this is now Lower Bear Trap Creek, heading down around the corner toward the water treatment plant that you saw in a photo earlier. And so just to point out, all the channel components that you see have been harvested or manufactured in drainage or on site. So all of our willow cuttings have come from the Upper Blackfoot drainage. We've exhausted a lot of our supplies in the immediate drainage, but there are some secret stashes that the stream restoration contractor knows about that are just about a 5-mile drive away. So they go and harvest willow, they bring those up, we soak them, we put them in the stream banks. All the channel alluvium is being generated from this town site borrow and mixed to meet our sediment size gradations for the channel to have a stable bed. And all of the floodplain fill that goes into the restored floodplain is also coming out of this town site borrow. So that picture I showed early on, looking up toward the tailings impoundment that had houses and power lines, that all kind of existed up here on this bench that we've now cut down because we're harvesting all that material for channel restoration components. So up in the tailings impoundment in Mike Horse Creek, it was nice. You know, yeah, the valley was kind of confined. The impoundment area was you know, a big chore for DEQ to remediate and remove all the materials. But as we moved down Upper Bear Trap Creek, site conditions got more difficult from a materials transport, channel construction, floodplain construction standpoint. So this surface is a clean, left behind remedial surface. Same is true for the other side of what's left of a haul route for those trucks, which is still contaminated. So they're trying to maintain efficiencies on the remedial side of things for removing all these tailings and contaminants. So obviously you can't build a stream channel that's designed to meander right down through that until all this stuff's out of the way. We're meeting our site-specific cleanup levels. Then we look at where that surface is. We evaluate it against our restoration design and keep hard charging forward. This is just more channel construction and floodplain construction as we move down valley. We have a big boulder matrix that ultimately got buried inside a bunch of smaller sized material. That was for vertical stability so that we didn't downcut the stream on a fairly steep stretch. Down around the corner again is where the water treatment plant is. But if from that last photo, this channel is where that High Point road was. So that road's been removed. These are the floodplain surfaces that are left behind. And this is literally sitting right where that old haul route was. So we've come in right on the tail end after they've obliterated that haul road and built stream channel. This is just some more channel construction that's occurred this year. We're moving down toward Anaconda Creek, which is the upstream-most fish-bearing stream in the Blackfoot proper. This is Lower Bear Trap Creek, moving down toward our confluence with Anaconda Creek, and the official geographic starting point of of the Blackfoot River. One of our big design challenges this year that we seemed to work through fairly quickly and quite easily was, this is Upper Bear Trap Creek coming in. This was the proposed excavation limits for remediation. This was our proposed channel alignment for Anaconda Creek. Turns out that there's a big knob of high quality, old growth, mixed fir and pine forest with just a skiff of contamination on it. But for the most part, really looked like a surface or a place that we needed to preserve in place. So when we're out there, this channel meander bend actually doesn't work. And this confluence location doesn't necessarily work. This channel alignment definitely doesn't work if we want to preserve all of this, the good stuff that we still had left behind at the site. So an alignment shift had to occur in Bear Trap Creek. A big alignment shift had to occur in Anaconda Creek. And we made that adaptation on the fly. We didn't go through a big restoration redesign with new plan sets and all that. That was one of those, we're ready to build it now. We know we want to save this. We looked at how to do that and worked out a way. So this is that big terrace full of really good old growth that we were talking about. This is Lower Bear Trap Creek coming around the corner. It was originally proposed to swing all the way out and would have actually dug into those trees. So we made an alignment shift there. This is Anaconda Creek, threading the needle through all this old growth and coming around. And this rock is the cornerstone of the geographic start of the Blackfoot River. So if you ever want to go sit on that rock, you will be at the literal starting point of the Blackfoot River. So that's where Anaconda Creek and Bear Trap Creek come together. So that's kind of one of those design iterations that you do on the fly. This is Anaconda Creek looking downstream toward the confluence, which is out here. So you can see we've built some stream banks. This is a big channel plug, but we've weaved this thing down through that old growth. And there are already fish recruiting into this new stretch of stream. But what's that leave? Oh, sorry, I have one more photo of Anaconda Creek just to show how we had worked it through all that old growth. This tree actually got knocked down but left intact and spans the channel. There's a lot of really cool stuff we used in that stretch of Anaconda Creek to get it down to the official start of the Blackfoot River. But what's that mean for Dave and my future? Well, we have 2 more major phases left to go. Couple 100,000 cubic yards of tailings have been or to be removed. And so this is downstream of the water treatment plant. This is essentially what's left behind for winter of this year. Blackfoot River flows are going to be in a big giant pipe. We'll do some other erosion control BMPs, and we'll hard charge into 2019 to get this surface restored like the other ones that we have. That's all I got. Any questions?